Hey guys, I'm standing right now at the base of a waterfall in Iceland called Skogafoss. A lot of Iceland's power is driven by hydroelectric energy. This is energy that comes from the movement of water like this, or comes from the tides, or comes from rivers, and usually harness it using dams or other kinds of things that can basically turn turbines and generate electricity by the movement of the kinetic energy in the water. And waterfalls like this are a huge source of that hydroelectric power. Now, way more of Iceland's energy comes from geothermal energy, but this is still a huge source because glaciers are melting everywhere. There's a lot of rainfall, and you've got a lot of moving water like this that can create energy for the country and for the cities in it. In this shot, you can see two totally different kinds of water. Right behind me, this little pond is actually fresh water that's coming from a stream head, goes back into the forest that way. And if you keep following this stream, you see a little dam, and then it flows straight into the ocean, where you see a lot of salt water. This area around the stream that goes into the ocean is called a riparian habitat. And it's really, really lush, full of a lot of vegetation, a lot more tree cover than if you go further away from the stream because of the amount of water that the stream brings to everything around it. That tree cover can then shade a lot of animals and give them places to live. And these little small ponds and inlets that go into the ocean are really good homes for sea creatures as well as land creatures that can be in this kind of mixed water that's a little bit salty and a little bit fresh. Not so salty that it's so damaging to some animals, and not so fresh that it doesn't have the minerals that other animals need. And so these things become these types of areas called estuaries, where the water from the fresh water from the streams meets the sea. And it's often a really good habitat for small creatures that are just growing up, they've just hatched. And a lot of fish will actually lay their eggs in areas like this in order to make sure that their young can survive before they're big enough to get out to sea and be in the big area where a lot of predators are located. Behind me is a river, and this river is flowing into the ocean, coming from a glacial lagoon. You can see over there a little ice thing, a little icy rock. And that ice rock came from a glacier, broke off the glacier, and is now floating down the river. It's going to keep floating down this river until it eventually makes it to the ocean. This ocean is called the Diamond Beach because of all the little tiny icebergs that are just kind of floating around there. Some of them wash up on shore and look like little crystal rocks on shore, but then eventually they melt down, water down, and then join the ocean again. The other thing you'll notice, of course, is that the sand on the beach is completely black. Here's a little view of the beach. You've got some larger igneous rocks as well in a pile over here, but down here you've got this dark colored sand along with a couple of other small igneous rocks. Those are all broken down from the mountains that were formed from volcanoes a long time ago. Behind me you see this beautiful, very still lake. But on the other side of me, there is a steep drop-off. I'm actually standing at the top of a river dam, and this dam is holding the reservoir water in place. So this lake behind me is called a reservoir because it's basically man-made. There was water here naturally, but when we make reservoirs, we build a dam or some other type of containing structure to hold the water in one place so that we can use it for drinking water, we can use it for boating, for sport, whatever it is that we need. Well, we don't want this to overflow. So there's this little bit of ridge right here flowing under where I'm standing. And when it gets too high, that extra water flows down this slope and continues on into the forest. So this dam keeps this river at the level that we want it to be at without it going too high. Of course, you could go too low if we run out of water, if there's a drought or whatever. But for the most part, this lake is going to be at a stable level because of the dam. One thing you might be able to notice behind me is that there's a bunch of different levels of pools. Depending on where the rocks are, water will collect in higher or lower places, then just stay trapped there until the tides come in again. And so some of the organisms that are adapted to that area, if they get a nice tide pool to live in, they can avoid a lot of the predators for that entire sequence of night and day until the tide comes back in again. It's kind of hard to tell, but we're actually in a high tide situation right now. And the waves, which were in the sand earlier, are quickly closing in on little old me, as isolated as I am. You can see the sun in the sky, and you can imagine right now that on the other side of the world, you've got the moon, and that moon's gravity is kind of tugging on China and the other waters that are there. And by doing that, it's actually tugging the earth a little bit towards it, and because of that, the water here has less land underneath it, and so it's a lot higher to us. Now, a lot of the animals and plants that live in the water up in this high tide region, they are only underwater for maybe once a day, for an hour, or even less. So a lot of times the adaptations they need are ones where they're in the sun a lot and they can't get the oxygen from the water that they would normally be able to get if they were underwater all the time. If you go down lower, there's actually a low tide region where animals that are underwater for most of the day and above water for just a little bit of the day, same thing happens. They have to find a way to adapt to just being in the sun for a bit and being underwater for most of the time. as you'll find different animals and plants living at different depths and zones, depending on whether they're adapted to being mostly underwater or mostly out of the water. So now we've got a low tide. The sun is directly behind me on the horizon, and the moon hasn't even risen yet, but it's right on the horizon on the other side. So neither of them is really pulling on this water. It's not pulling it up, it's not pulling the earth out from under it. It basically has an effect to just kind of keep it flat. And so all these rocks were completely underwater before, and you can see those high rocks there that were kind of where I was standing before. Now down here, there's all these organisms that are kind of in little tiny ponds and lakes that used to be completely underwater. And they have to deal with these birds you can see behind me in the background who are coming around, walking around, and picking off food really, really easily, whereas they were safe underwater before. This zone is for some of the most fragile life forms, because if they go any further out to sea to avoid the birds, then they have to avoid the big fishes. So this is a place where the fishes don't really hunt because they might end up washed on shore, and the birds can only hunt at one period of the day. So these organisms have to find a way to hide. And actually, the sun crabs and anemones and things that are hiding in the reeds and under the rocks there, they're hiding from me because I cast a shadow and they're afraid that I'm actually a bird. And so this is the kind of camouflage and little nestling adaptation that these kinds of animals have to deal with. So you guys were asking, what is it like to get through a cloud? Right now I'm walking on a super foggy day to the point where it seems like it's raining, but there's actually no precipitation coming down from the atmosphere. All of the precipitation is just water that's close to the ground, which we call fog. But it feels the same way as a cloud. The water particles are really far apart, so they don't fall unless they get wrapped around some dust or something or condense around each other. But you walk through enough of it and you still have water on my glasses, water on my mustache. That's what it'd be like if I was somehow Superman or something and could fly through clouds. I would feel the same sort of water start to condense little by little on my face and body.